like something happening because it would help me because every single time I take a test and I enjoy myself seeing this good on the test. So like, okay, it was like, you know, positive correlation there. So yeah, it's kind of an anatomy test today. I think I did really good. So then drinking my Celsius, but now my stomach hurts and now my head hurts.
Did you do anything else today?
No. I really just wanted to check out. After calc, of course.
Of course.
Yes.
You figured out that I'm always listening.
Yeah. I know. I'm loud.
Yeah.
That is so true. I feel like we're the only ones that talk.
Taylor, I'm here.
Oh, yeah. Oh, I turned it in.
I think I'm doing class. Okay, so until 1 p.m.
Yeah. So I have my phone to do homework today. It was class 8:30, and I was like, oh, I have to do my stuff. My computer, my phone camera.
In person.
To take pictures, and I was
I
like,
took
really?
pictures, but I don't know if they're like.
It's like a folder. Yeah, no, it's good on the
Pictures.
phone 'cause you can scan as a document.
If you do it Google Classroom, you don't have to do hand copy.
Okay. Well, I just want to make sure you can like actually see them because I don't know if they're good pictures.
Yeah, my pictures are bad.
Wait, are we starting in the circuit?
If you didn't put it in Google Classroom, so just kind of the last chance for full credit. Yours looks fine. I heard baseball's not going so well.
Well, we got swept this week, but we did play probably the best team in the state. So like,
You got swept, but didn't y'all like not score? And
we gotta shut up.
I've just heard some of y'all complaining about it. I guess some people are kind of mad. Oh, I guess our bells are turned off. All right, I had asked you guys to put the Circuit 101 in Google Classroom, but if you forgot to do that, you should go ahead and turn in your hard copy. Again, you don't have to do both, but if you forgot to do Google Classroom, this is your chance to still get full credit on it. Or I guess if you don't have it finished, you should at least turn it in to get some partial credit, but you need to do that here before we get going. And then today's lesson is going to be very similar to what we did last time. So I'm going to show you some very short and sweet notes over what's called the washer method. We did the DIS method last time. I'm going to have you practice a couple of those in Khan Academy, just one assignment, so that you can have a little bit of practice under your belt. And then I'm going to ask you to go back and finish one of those assignments that we've started, but I did not give you time to finish and I did not make a homework assignment yet. Any questions about the plan for today? Okay, so if you feel comfortable with the DIS method that we talked about last class, then the washer method is really just an extension of that. It's very similar process, very similar logic behind it, a lot of the same setup and all that kind of stuff. Okay, so let's go ahead and just dive into this. Pretend like it's this method for just a second, and then I'll show you how it's different and what you need to do about that. Now, of course, it's going to help if you give yourself a visual. Of course, it doesn't have to be perfect, but the better your graph looks, the easier it may be to comprehend what's going on here. So y equals 0, which would be the x-axis, x equals 1, which is a vertical line, and then 3x minus 9, which is mx plus b. So y-intercept, and then use the slope to get some more points. Basically what's going to happen is we're going to have an area trapped between those in the enclosed region, just like before. We are still going to rotate it around the x or y axis. Now when we come back from break, we'll rotate it from around other lines besides the x and y axis, but it's not too different. So when I rotate this guy around the y-axis, what's going to happen is the outside of this shape is going to make those cross sections. So this is almost the same thing as this method, where we can say rotating it around the y-axis would be dy. Because it's dy, we need to give our limits of integration with respect to y. So it goes as high as 0 and as low as, what's that y value down here? Where these intersect. -9 is way down here. Okay, and then so if we're only looking at the outside, then if we try to do this, we try to add up an infinite number of circles like we did last time. You're going to think of pi r squared, where r is going to be, since we're sketching in a few of our cross sections, we can see the radius length. The radius length is not always the same, so it's not just a number, but the distance from the x-axis to this function, we always call that distance x. But we needed these variables to match up. So instead of calling it x, we're going to call it 1/3 y plus 3. We're going to do it in terms of x. Now, here's what is different than what we did last class. Again, I know this is kind of hard to visualize, but do you see how this line, I'm rotating it around this line right here, and when I rotate it, do you see how there's this gap in area here? So when you rotate it, there's actually going to be a gap in volume. This right here is going to be completely open. Do you see that when you spin it around? So this picture up here kind of shows a better representation of it. We have the outside one that gets the whole shape, but if there is a gap in area, when you spin it, you're going to have this gap in volume that's not actually part of the three-dimensional shape. So all we have to do is come back and say, well, wait a second, then let's subtract away how much is missing. So this is the part that would be missing. So pi r squared, this length is always the same thing. Notice my circles are all the same. Well, again, this is where it helps if you have a good picture yourself. But all of these gap cross sections in here have the same radius of 1. So that radius is always 1. It's not dependent on x or y. So really what we're doing is we're taking the volume of the big shape and then coming back and saying, well, wait, some of this is actually not filled in, so let's subtract how much volume is missing. This is called the washer because it has like an open piece to it. You guys know what a washer is? Like you buy furniture and you have to put it together, like it usually comes with a few washers. Okay, but we usually write it like this for convenience. Both of these have a pi. Oh, this is still -6 to 0. It's got the same thing. It's going to have the same limits of integration. Both of these are dy. And then we're just subtracting these. So we have big R, the big radius, minus the small radius. And in fact, when this shows up on FRQs, that's one thing that they often look for is this. Did you show big radius minus small radius? And then that integration would give us the volume of the shape with that hollowed out center. So a little bit harder to visualize than the last unit because we're kind of doing 2 in 1 and my picture kind of gets in the way of itself. But again, if you can find the volume of the overall shape with the disk method, you're just coming back and subtracting, basically doing the disk method a second time. You're subtracting how much volume is missing. And it's kind of nice to just combine these into one big statement. And in fact, I think you should probably write on the top of your page, when we do this, you're going to integrate big R, oops, well, it's always going to be pi r squared, but big R squared minus little r squared. All the washer method questions are set up that way. Okay, so the next one is also spun around the y-axis. So go ahead and try to make this picture. Try to set up your integration, see what parts come quickly to you and which parts you struggle with. But I've only got two of these for you to try on here. So this is the only one to spin around the y-axis. So please try that while I also work on it. And of course, the bigger and better your picture looks, might be the easier it is for you to see what's going on. So try not to skimp out on the picture too much. Okay, so this was the area that you were trying to spin, and you were spinning it around the y-axis again. We're just doing one of each, but dy. So you should be looking at the bottom y value. My picture is not the best, so I think that should be 4. Is that what y'all got? Because that's when x equals 2 is in the same place, same time as y equals x squared. That's where I'm getting at. And then 9. Now, if you're a little more artistic than me and you can draw a picture and your picture kind of helps lead you into your answer, then that's great. But by far, what I think is the easiest is realizing that when I spin this, again, I'm not going to do a lot of these, but I'd like to do a couple. When I spin this, the outside one, so the big radius, is always this length, which is x on the equation this. So the big radius is the square root of y. And then you can do a whole separate integral if you want to, or just combine them together and then do minus the small radius. And the small radius, again, I almost have to, there gets to be too much here. But the small radius will be this. This is what the 3-dimensional little gap is going to be missing. He always has a radius of 2. But I did not put down the most common mistake. What did I not put down?
Pi.
Right. These are a bunch of circles, so it's supposed to be pi r squared minus pi r squared. You better put the pi there, or it's not going to work. So if you would rather do two separate integrals, work it that way, it's fine. But make sure that you see how those can be pushed together. They're both dy, they're both 4 to 9, they're both pi r squared, so you can put the pi out front, it's like GCF. But always big R minus small r. And that would what would give you that three-dimensional shape, even though it has a missing inside there, missing volume. Okay, any questions about that one? Okay, then you can probably guess what's going to happen when we spin it around the x-axis, but let me go ahead and do one for you and have you practice one before we go on to the second thing in the lesson today. So again, we need to graph this guy. At some point, graphing may not seem necessary, but that's probably not going to be today. Maybe I can color coordinate these a little bit. But you have to identify the area that's trapped in between all those curves, all those equations. And then if we're going to spin this around the x-axis, so we're going to spin it this direction, so I didn't plan my picture out the best, but that is going to be, I'm just going to do it in two and then I'll combine it in one. So I'm going to think about the outside of this shape. So it looks like from 2 to 3 in the x direction, spinning it around the x-axis. So I'm just looking at this big overall shape. Looks like he always has a radius, and if you don't draw in a couple circles, it's hard to see that. But spinning this around the x-axis is always going to create the same cross sections where the radius length is 3. So that would be like if there was not this gap in area, this gap that's missing. So we have to then come back and say minus pi r squared again. Got the same bounds from 2 to 3. But now this part that's missing, the area that's missing that's going to create the volume that's missing is this. So sometimes that radius is 0, sometimes that radius is 3. But what all of these have in common is all of these have this length in common, and this would be the y value for this function that's in red. The distance from the x-axis to y, distance from the x-axis to the function, we always call this y. But we need these variables to match up, so don't call it y, call it what y is equal to there. But in the end, you know, again, there's nothing wrong with this as long as you can match it up to multiple choice, because I think I have seen some like that before where they don't expect you to solve them. They just want to see that you can pick out how to set them up. But you could combine these together. But then you should do big R minus little r. Big radius minus small radius. These two say the same thing. To me, it's really just easier to go straight to this than it is to do it in two separate parts, but you cannot make assumptions. Usually the part that you're going to cut out has a fixed radius, not the outside shape, but in this case it was. And I wouldn't have known that without the picture. So the picture is certainly going to help guide quite a bit.
Wait, where did 3 come from? Like the 3 square to the...
That's the big, if I took from the outside, this would be the radius. So if I spun it around, this would be the cross section. But if I scoot over a little bit, this is still the radius. The radius is still 3.
Okay.
Scoot over, the radius is still 3. So the big outside shape that would be the complete figure if there wasn't a missing piece would be 3. Okay, so try one more. This one you try on your own before we talk about it. And yeah, I don't want to give you any hints, but revolve around the x-axis. Okay, so to try to give you a different kind of look on this, to help you see it connect a little bit to what we did last time, let's pretend for just a second that there's not this gap in area. We're spinning it around the x-axis and there's some area that doesn't directly hug up next to the axis we're spinning. That's what was not true last time, which is why it was disk. But let's pretend like this was all the way full. The disk method would just be this part. And so when I rotate it, we would get really big cross sections up here to no cross sections there, and then stuff in the middle in between. So since we're just adding up an infinite number of circles, it's always circles for these question types. It's never going to be another shape. Now those known cross sections that we did that I'm going to ask you to go back to, you've got to do different formulas for those. But on these, it's always circles. So pi r squared, and then the radius looks like it's always this length, and then this length, and this length, and this length, and it looks like that length is always, this is my x-axis. So this length is always y for this function. So that would be x squared. Distance from the x-axis to this curve, which is x squared, is always the radius. But what makes this a little bit harder now is this area didn't actually exist. Or this area didn't exist, so when we rotate this, this volume's not going to exist. Oh, but we only want, sorry, my pictures are a little bit misleading here. We should only be going to here, not further over, because that's not part of the area. So the part of the area that's missing, which would be rotated and create volume, so the volume that's missing, these always have the same radius, and those is from 0 to 1, so those always have a radius of 1. Big R minus small r. And good idea to just go ahead and combine them.
Bounds.
Oh, the bounds, yes. So this would be 1 and 2. Because you're looking at the x direction, because it's dx, not 1 to 4. So, unfortunately, I know my pictures can almost be more hurtful than they are helpful because you get so much going on here. But again, I think this top one, this is what we're aiming for here. This is the most concise way to show that, but it's really the volume of the whole thing, and then come back and subtract the volume that's not actually going to exist when you spin that figure. But this picture up here does, I think, the best job of showing that. So if you did an integral like we did last time to find the area of, or the volume of this blue container, that would just be the disk method. Coming back and subtracting all of this volume that's not really there. When you also do that, then you're getting the washer method. So this is, washer is like a circle with a hole in it. So each one of these little cross sections looks like a washer. That's where it gets the name. Okay, can you see any questions you want to ask yet? Yeah.
So on the third one, why wasn't it like, just, why did the one that had the intubations come after, or did it come after like this?
It's just based on how the area was. When you spin this figure, the outside, the big radius was always the same because this was flat down here. But the small radius, what's this? The small radius, which was this, is the one that changed.
Oh.
Yeah, and that's really hard to see, and especially when my picture is super small. But your picture, if you imagine rotating this volume around, I can kind of do that, but then you're going to have big radius, which is always 3, whether you take the cross section here or even over here, the radius is still 3. But then the small radius, the part that doesn't exist, changes. It's always whatever this length is. The big radius can be just a number. The small radius can be just a number. I would say the small radius is more often just a number, and the big radius is dynamic in terms of X or in terms of Y. But it can change question to question. And again, if you don't have your picture set up to where you're carefully picking out your big R and your small r, then yeah, you're going to miss it. That's really the challenge in these, because all of these are set up the same way. All of your answers are going to look like this. Oops. All of your answers are going to look like this, except dx, dy, and bounds. But you've got to slow down and think about how big is the big radius and how small is the small radius. And it's going to change question to question. And your picture is probably going to be what determines whether you get that right or not. Okay, so let's have you practice a few of these and see where it goes. So scratch paper for 106. Again, it is only one Khan Academy. There is some others that I could have assigned that go with this, but I'm letting you guys just focus on spinning around the X and Y axis this time. When we come back from break, we'll do things like spinning around X equals 1 or Y equals 1, which is really the same type of question, but it does make finding the radius a little bit harder than this. So I'm trying to give you the easiest questions that I can for your first try, but it does take some practice, I think, before you kind of hone in on what you're looking for. So, like we did last class, I'd like you to prioritize this first. So I'll give you a little bit to work through it. Click the Get Help on the ones that you miss so you can learn from your mistakes. And then once I think everyone's kind of done that a little bit, I'll come around and try to give more assistance beyond that. But I'd like you to do that first. And then from last week, we did volumes of solids with known cross sections. That should be 102 in your binder. So I'd like you to get that out, review what we did together on that, and then work on finishing that up. In a lot of ways, this is kind of like area between two curves, where if you know how to find the area under a curve with integration, you just come back and subtract the area that's not really there. So if you can really find volume from this method, it's the same thing, but you're coming back and subtracting the volume that wouldn't be there. So kind of a similar thought process, at least. Now, also, I think the Khan Academy I picked out has pictures on all of them, so that should make it quite a bit easier for y'all to correctly pick out the radius, but that's still where you should slow down. And just for time purposes, do all the integration in a calculator. You don't need to integrate these by hand unless you really, really want to practice. I do think all of these ask you to put your answer in terms of pi though, so if you don't remember what that means, you should ask that right away because you won't get anything right until you're sure about those directions. If you do click the get help when you miss one, it does try to show you the washer, which makes it a little bit easier to see what the big R and little R are. But you guys do have only about 30 seconds here till your lunch break, so try to finish up your thought. You can work on this when you get back. Our bells are turned off, but it is time to start back. So, quick real reminder, you guys had just started on this Khan Academy before lunch. Again, there's only one of them. So at some point, if you kind of hit a wall, trying to get 100, something's not working, you're still not figuring it out, please let me know so I can help you. But that is top priority. Finish that up. So I know some of you already have that finished, which is great. If you don't, please try to finish as soon as possible. So if you need help, there'll be time to help you and get us all on the same page. Then once you're finished with that, handout 102, where we integrated area to not just circles, but other things, which is called volumes of solids with known cross sections. So we spent one class period on that, but I did not ask you to do it for homework because you had a test to study for, and I did not give you enough class time to finish it. So please continue there. And of course, if you guys have questions on that, then please ask as well. I'm not going to insist that you turn in 102 today, but I will be asking for it when we return. And of course, 9 days away from school, that's not going to be on your priority list. So you should have just I don't know, like maybe 8 more of those to go or something. But if you have any questions about how to do that or the directions, please ask as soon as possible.
Mr. Thompson, do you have a Chromebook charger?
Do I have a Chromebook charger?
Yeah, mine's
I do. Oh, well, what kind?
flat.
Yeah. You want the one that works or the one that doesn't work?
One that works, preferably. I don't think this one works.
Oh, I didn't. Sure?
Yeah,
Oh,
it's not like
I didn't mean to do that to you. I think that actually is the broken one. I don't know why I use it, but I just feel like it's gonna have a use someday. Yeah, that one doesn't work. I don't have anything for you.
It's minus my cube square. Because whenever I do this, the what? Oh, so it's 1 to 0? Yeah.
How many times did you have to try it?
Slower. And double tap.
It's one or two, right?
One third. Oh, yeah, one third.
What's good? If you get a semicircle, right? Wait, I don't know. Mr. Johnson,
Yeah.
For these cross sections,
Uh-huh.
can you remind us, when do you like multiply by two, like divide by two, like do something else to it?
Multiply by 2, divide by 2.
Like, you have to add something to the equation.
You should be integrating the area of that shape.
Yeah,
The area formulas are going to be on your front page.
yeah, we want that. But,
Okay, so, but then to find the base length, you need enough of a picture to see, like your base could be y, it could be 2y, it could be half of y. Depends on the shape and the picture in the problem. So like this one, this would be the base. So if this one says y, that base length is 2y in that problem. Over here, it looks like this would be the base, and that would be y and y, so that base is 2y also.
okay, so what are we, oh, okay, so this is this thing is
The
y.
base is the thing, this is the part that's sticking up in the air, the point. So
Oh.
this is what's on the flaps where the circle
Okay,
is
yeah,
at,
that makes
so that's what it's the base.
Okay, but then from here to here is y, so we need to do both.
For that one, 2y.
Okay, and this one would be like that too? How it goes up? Y, and then.
Well, that's half of the circle, the semicircle, so half of pi r squared, half of pi r squared. But this case, your r is just y. So sometimes your base can be 2y, sometimes your base could be, or your r could be 1y. That's why you clean on the picture of y.
So you don't move the 2y here because, but isn't this, would that actually r, so.
Correct.
So you have it on half, but you, like.
Well, but the area of the semicircle is 1/2
Mhm.
pi r squared. It has nothing to do, you don't
Okay.
want diameter, you want r.
Oh, okay.
And this would be r.
Oh, I see, so you want base here, which is the thing.
Well, okay, so for semicircles, you can do one of two ways. I think it's easier if you do 1/2 pi r squared and then just look at how big your r is. Technically, if you wants to memorize that guy, the base would be the whole diameter, and then you could use that formula instead.
Okay.
But to me, that's an extra formula to memorize when you really
Yeah.
should know half of a circle. And then this one I have to look on, because that one, remember, is a little different. You gotta think about what areas over there. There should be solutions on the website. One of the problems though is the work. I didn't do the work, so she, I think it's Ms. Cross who did it. I think she often finds like half the volume and then doubles it. So like maybe instead of integrating from -5 to 5, she might just integrate from 0 to 5 and then double our answer. I don't like doing it that way, so the work won't match, but the final answer should still match. So that can help. And you can, I mean, you're supposed to be able to integrate by hand,
Relearn
but
this.
there's really not that.
Before I go on. So I want to make sure that.
But thank you for asking.
Oh, so for all of them, you have to do 2 of them. But all of them go down to the, this one, this one you do 2. And this one. Yeah, no, yeah, you, oh, because it's already half of it. Is it the same as one?
This is something like
base.
It's since 4 days is already.
These are it's usually appendix. I think so. Yeah. Yeah. 2 times y squared. No, 2y squared.
Yeah,
Is
so
it
you have 2 lots.
2y squared? And then this one. What did you write the equation for? Did you write the equation for?
I think so. Just be like the base square, but I
Can you look at the equation? What's the equation for that one? Two. Oh wait. Is that 2 times 2? Is that
is there 5? When does the cap
so it'd be oh, that's weird.
Yeah,
How does she do that?
I don't know. It's like I'm giving you like
That's
this
weird.
is when she does it. It's waiting for us.
So it would be 4? You said? Oh yeah, multiply the 2. Oh, because that's how you do.
She's double that.
Oh, because the length one is multiplied the space. So that's what and then you do everything else the same.
So I guess it's
Times. So 2. Squared. Why did it not squared?
clock at about 16 minutes. So if there's something I can help with, please let me know as soon as possible.
Wait, I got 1,003 for this game. What'd you get? I have 2,000. What'd you get? 2,003.
But I'm not getting the I'm not getting it.
Oh, I put 2 in that. Well, it doesn't matter. You just lost that by 2. Well, yeah, because it's square. Inside. That's what's up there. Inside. What did she get? She got 4,000?
Yeah.
But I'm still getting 10,000. Wait, what? Wait, what? What? Because I'm playing. Like, you know how you put them in the front too, right? No. That's not how I'm doing it. Oh, that's one that's not the same. Because it's square. And that's right. You hit it on that. No, I didn't on that one. Like on this one, I put it inside. But on that one, I put it outside. It's the same group of one. Oh, so you have to do it twice. So 2 times. Oops. And then 2. It's 5, 5, 5, 5. Okay, now I'm getting 4,000. Oh, because
Put someone outside and one inside.
yeah, because remember the height, the height was supposed to. But with this one, I'm seeing 1,000.
Well, cause you just put someone inside.
Oh, I did. Did I know it? No, I didn't. I'll try it. Okay, so now there's that. What'd she get for 500 everything?
Yeah.
These curves, she multiplied the same circles by 2. I'm sure I'm not supposed to.
Yeah, she did.
That's,
She did 185, and I was just like 2.
When you took your
25.
Yeah, I bet she did 0 to 5.
Right, but then she,
That's what
yeah, but then she also put the 2 on the side. And she was like,
Yeah, because she did the semicircle equation when I had the square. I just did pi r squared, or 1/2 pi r squared.
I just wanted to say that like you need to be careful comparing work because if you're integrating from -5 to 5, which is the way I should do it,
she's integrating 0
yeah, and then she's doubling it.
Yeah.
That's why one of those two is on there. So
Okay.
really, I don't want to use that for the final answer. I wouldn't worry about the steps.
Okay. So
Like now, if I insisted you integrate all those by hand, it's kind of nice for one of them to be 0.
Yeah.
Because some of it goes away really quickly.
Yeah.
That's kind of why some people do that, but it's one more thing to know. So, and if you try to do it when you're not supposed to, then you can end up messing something up.
Can you check?
Okay.
I don't want to get it wrong, and it's the last
Well,
one.
you can tell me what you think, and I will tell you if I hear anything wrong.
I got this pi, but I did 1 to 2. This side's 1 to 2, and it's the y.
That's the y. Okay, but you did x. But, okay.
Well, I had
Yeah.
2. And then yeah, I can't get
So-
so I did.
Hold on. Around what? X? Around y.
Around y.
So where's your big radius?
-8.
Okay, that sounds right.
On the left and then I think that's changed it. Or it's changed it.
That looks good, too.
So, and then that's what I saw.
I
I don't really know how to base it based on high school. That really confuses the heck out of me.
Let's see if it turns to a fraction.
That
I
just
think you said to
confuses
have like
us.
17.
Well, and pi.
2 or 4. Yeah.
You don't know how to
Right?
you know how to
Two
change this to a
inside?
fraction when you calculate it.
Wait, did it
Yeah.
just say that the height was?
Some of the answers
4?
look like that. Everything you said sounds fine, but I'm
No,
not
it said
responsible.
length is on the base and the
And
height is
y.
4.
Oh, just the height is 4.
Yeah. It's just really confusing me, the wording.
I was like,
That's almost even more confusing.
well, no, but like it gives you an idea.
Does anybody think Arkansas is going to beat Kansas?
I do. I think
Yeah.
they're going to.
I want to remember who says that. Y'all are delusional.
I have a bet on that. So I hope
What?
they win.
You would bet that?
It's only $20.
Oh.
That must be made of money. What do you win if you're right?
$20.
But you should be
What do you-
asking for
what do you
more.
think?
Well, like we're both just like it's like $20.
Yeah, but that's
They
like if
win.
it's an even chance. Arkansas is a big underdog, so you should win more.
Yeah.
I don't know.
You're getting
I don't
scammed.
really bet that often, so.
Well, that's good.
Is it with Zach?
Yeah.
Yeah,
It's the same
that's a
thing
fat
too, I
bet.
swear. He wanted to bet $100 on me, but I was at risk.
Of course he does. Kansas is
Oh,
the
okay, that's
one
what I got
seed.
too.
Yeah.
Just her keys.
Yeah, that's why I wasn't even looking at the key.
Now, what if Kansas loses their first game? Then you automatically win, right?
Yeah,
Because they didn't.
I really don't see that one happening.
I don't know. There's always a lot of surprises.
Are you a Kansas fan?
Me? No. But I just realized that when you're from Arkansas, you want to think your team's better than they really are. So,
Yeah.
I mean, everyone does that. Some sort of
Well,
bias.
like last year, they did like I always make a bracket with Arkansas winning, like one of them. And last year, I did really good. 'Cause they won so far. It's gonna drive me crazy. I always have to have some hope.
Always have what?
Some hope for them.
Oh. I don't know. Arkansas does pretty good, all things considered, but like if you were like one of the best athletes in the nation and you lived across the country, like what's your draw to come to Arkansas? Like unless you have family here or something, like it's pretty unlikely you're gonna want to play for Arkansas. So recruiting is just a lot harder.
0 and 4.
Well, just plug it into your graph.
Yeah, I'm getting.
It's too bad you guys are so young.
I can't turn into
The Razorbacks used to actually be really good. Those were the fun days. We would have like I was in elementary school in March Madness. They'd always roll in the TV cart, and we'd get to watch the Razorback game.
Can we put the games
They
on
still
here?
do that.
Or what time is it? Oh, it's
They do rolly carts.
In the library.
Oh, they do.
They have
I
them
can't
in the
believe
gym.
we.
Oh, negative
You see what I mean?
0.236.
I didn't think those
You
things
can't
existed
round it.
anymore.
You can't round it. What's negative 0.236068? Fraction. Or would you still round it? Or what fraction is that? I don't know. Oh,
It's okay.
no, but because you know it's not exact. I'll just do 0 and 4. Because 0 is not where it intersects at that side. Oh, it intersects at 4. On the right side at 4. Here, I'll just look. Oh, she used quadratic formula. Or you have to complete.
What?
Or you have to complete the square. So like, x is gonna be 2 plus or minus the square root of 5.
Okay, that's all.
Negative square root of 5 plus square root of 5 balance. Huh?
I don't know. I'm not doing quadratic formula on these.
Oh, wait. Yeah, yes.
That's not it.
So,
Is it Zach Johnson?
No.
Oh.
Zach,
2 plus the square root of 5, 2 minus the square root of 5. That's the distance. Well, it's not 7.2. 2. Wait, should I again? They round it.
I'm gonna have to tell your mom she gives you too much allowance.
No, it's not.
she didn't give me any allowance.
Oh, how do you earn money then?
I have a job.
Oh, it's
Doing what?
2. Plus or
I
minus
babysit a lot,
the
and
square
then
root
I
of
work
5.
at my club team
That
for
makes
volleyball. They like got a store, so I work
So,
that, and then I work all the
bonus
tournaments that they
2
host.
plus
So I
square root is 2 minus
Okay.
square root of 5. Yes.
How old of kids do you babysit?
all ages really. So
18-year-olds?
I mean, like, well, like, until like, they don't need one anymore. Like I babysat these kids and then they don't need me anymore. So, I've done like,
Oh.
You like change diapers and stuff?
yeah.
Good for you.
You're probably right. I just don't think that hurts my head.
Yeah, that hurts my brain too.
4 times 2 times.
That's why I left all the fun.
Squared 2x.
Yeah, that's what I'm gonna have on my calculator sometimes.
Does that make you want to have kids less? Changing diapers all the time?
No, I
I'll
like
do
it.
this during spring break.
All the time.
You'd be fine changing diapers all the time?
Yeah.
I'm not bringing this. I'll bring something that I bring now. I'll be doing my homework later. That's true. I don't like
All right, you guys have about 2 minutes, so please make sure you know what I need from you from when you guys come back.
I know I want to do it.
If you don't write it down or take a picture now, you may forget.
Wait, you have a spot in class?
I don't. Just have it ready to turn in when we come back. I probably won't ask for it the first day back, but I'm not going to give you more class time on it, so.
Oh, yes, I'll do that. Yeah.
Do it. Actually, I'm gonna forget about that.